Food safety is extremely important for everybody in and around the world. Just in the US, the CDC, the Centers for Disease Control and Prevention, estimate that there are 48 million people who get sick because of eating contaminated food. 128,000 people are hospitalized and 3,000 people die every year because of contaminated food. This is such a huge number. We are in 2023. We are the latest and the biggest and the most advanced nation in the world, and we need to make sure that the food that we are producing is safe for consumers. It's a huge onus on us as scientists as well as the industry and government. And so it is for us to develop new innovative ways that we can improve food safety for everybody and provide safe food for our consumers. I work on developing and testing innovative technologies that can improve food quality, safety, and shelf life. My research focus specifically is on poultry meats, and I work on poultry processing all the way to the product side. Some of the pathogens that I work on are like Salmonella, Campylobacter, Listeria monocytogenes. But over the period of time, we have also worked with some dairy-related pathogens as well to improve food safety. We're always working on something very interesting, innovative, and out of the box. We always like that kind of approach. I encourage that approach because that is how we get transformational change in the way we do things rather than doing the same thing repeatedly over and over and over again. So some of the projects, say for example in the food safety area, are where we are working on cold plasma, which is an ionized gas. I'm part of an NSF project and Auburn University is part of that bigger project as well, where physicists have developed this highly charged ions that are then streamed onto a food product. Now, physicists have done it at room temperature and pressure, and then we are finding applications for the things that the physicists have done. So this is our cold plasma equipment. What it has is an electrode in the center and a helium gas as our carrier gas. The electrode gets electrical input from this black wire, and once it gets the electrical input, it is going to ionize the gases around that electrode, and which essentially is air. And air has water in it, air has nitrogen, oxygen, hydrogen. And so you're ultimately creating reactive oxygen species, reactive nitrogen species, and several other ions, highly reactive ionic species that are then flushed down through this tube, which looks like the purple haze that is coming out. You can put your hand underneath and it's not going to hurt you at all. In fact, if you were to keep food products underneath, then you can actually kill bacteria on the surface of those food products as well. So that becomes a very innovative approach that we are taking at Auburn, and it is also a very interdisciplinary approach, a very convergent approach where we are taking physics and then and microbiology and making something completely unique for our stakeholders in the industry that they can use. Again, impact and our stakeholders again are very much at the forefront. They are the first we think of. Most of the research so far has been focused on applying antimicrobials and washing chicken and stuff like that at the processing plant, and we have reduced the microbial loads and pathogens at the processing plant. The chicken gets put in a tray pack or in a bag, and then it goes in a truck, and cold chain is the only way that we can control the growth of pathogens. It's one of the leading ways that is used across the world. However, we also know that there could be disruptions in the cold chain. Say, for example, the truck breaks down. Or it could happen that a truck driver moves the product from one place to the other, where they open the door, they deliver the food, At that, when they open the doors, the temperature of the truck, which is supposed to be 40 degrees, now has increased. And because of that, the product temperature has also increased. They close the door, the temperature goes down. And if they do multiple stops like this, the product that is in the truck is now encountering something called temperature abuse. So this poster talks about some of the works that we have done in that particular area. So what we did was we took literally a pallet of chicken over here. We not just work on small, one piece of chicken, but we actually want to mimic the real world scenario. So we take a pallet of chicken, which was commercially produced and processed, and we moved it in 4 degrees Celsius and pulled it out to room temperature at 23 degrees Celsius for over 24 hours. We did that in cycles, and we collected the temperature profile of the chicken because of that fluctuation, which this fluctuation in temperatures was to simulate what could happen in a cold chain disruption scenario. And then we took those boxes, those chicken trays, and then put them on a shelf, simulating retail shelf. And then we found out what would be the shelf life of that chicken. So we had chickens, the pallet had like 4 different layers, layer 1, 2, 3, and 4. And what we also interestingly found that the temperature profile of the chicken in the top layer is different than the other layers as well. And each layer is different, and the temperature profile of the chicken in each different box is also different. What does that mean is that if the temperature profiles are different, that means the chicken in each box or each of these layers is going to spoil differently. That means that adds new understanding for us to say when there is a temperature abuse that has happened, that we can potentially take one box out first that has been most temperature abused based on the data that gets collected using time temperature sensors. So beyond that, once we received the temperature data, we did the shelf life at the retail on a simulated retail shelf. We did something called Monte Carlo simulations, and we also did some prediction of shelf life. So we did some parameters called like risk of loss, meaning what is a chance that a box, what is a chance for a box of to have a shelf life of less than 4 days. And 4 days is an arbitrary thinking that a retailer may, that is their cutoff. Below 4 days, they cannot sell the chicken. So that would be their risk of loss. Below that, the closer it gets to 4 days, the more the loss there is. The shelf life remaining, meaning that because of the temperature fluctuation, how much shelf life is remaining on that. We can calculate the percentages on that one as well, and what is a shelf life reduction, meaning the proportion of maximum shelf life lost. So we did some mathematical equations to predict all these different parameters as well. And what we found from our shelf life study is that the chicken, on the x-axis you have time in days when the chicken was kept at on the retail shelf, and on the y-axis you see bacterial growth from 0 to 9. This means 1 means 10, 2 means 100, 3 means 10,000, 10,000, 100,000, 6 is a million, and 7 is 10 million. Anytime a chicken or bacterial population on the food reaches 10 million, that is when the food is called spoiled. So what we found was the chicken that was never temperature abused had a shelf life of 7 days, meaning the bacterial levels increased above 10 million at the end of 7 days. However, when we had the chicken that was temperature abused, you can see the shelf life of it was somewhere between 4.5 to 5 days. So that means a 2.5 day decrease in the shelf life of the chicken just because of fluctuation in the temperatures during that supply chain, during the 24 hours from the point that the chicken has left the processing plant until it has reached the retailer. So we did all these mathematical models, and then we came up with these things where now we are not only able to figure out how much risk of loss or shelf life is remaining because of the temperature abuse or the hours that the chicken has spent over 4 degrees Celsius, but now we can also figure out which box on the pallet is going to spoil first. And so based on this data and the time temperature data and these mathematical models, you can quickly understand, okay, box number 2 will have the least shelf life, so put it on the shelf first. Or on layer 3, don't worry about this and worry about this one first, or whatever that data tells you. Now you have made database decisions, and what that helps us to do is transform our understanding of warehousing and how we use certain terms. We are creating these convergent opportunities for students in our department to work on these supply chain. They understand now the poultry science aspect of it. They understand how the chicken gets processed, how we reduce bacteria and everything. But now they also understand theoretically and practically how supply chains work. And now they are microbiologists. They understand poultry. They understand supply chain. And that makes a very unique product in the market. I mean, these students who have gone out of my lab, they are probably some of the most unique students in this country.
One of the projects that I am working on is identifying fecal contamination, both visible and invisible, on chicken carcasses that are being produced in the poultry industry. Making sure that we are detecting the fecal contamination and also making sure that it is gone once it has been rinsed. There is a zero tolerance policy in the industry by the USDA, FSIS for poultry, not only for poultry but also other industries as well. But poultry specifically we are speaking on, I'm looking for fecal contamination, making sure that there is not any visible, and even with it not being visible, there can be invisible contamination, and that can cause an issue in the processing plants. Not knowing that it's there, it's not able to be seen with the naked eye. We see it with the UVA and UVB lights that this camera, a spectral camera, uses. So being able to do that, it really is very powerful. First, we are going to be working with a spectral camera on chicken carcasses and seeing if there is a presence of fecal contamination after it has been rinsed off with DI water, which is deionized water. So the first thing we're going to do is use a sterile foam tipped applicator, and we're going to swab the right side of the breast. That applicator will go into the tube and it will be incubated for 24 hours so we can do a salmonella quantification test to see if there was any presence of the microbe before we inoculated it. We are going to place the chicken carcass into this box that is used to remove any ambient light while using the spectral camera. The spectral camera will be using UVA and UVB light to capture any fluorescence that will be seen on the chicken carcass. We are going to take a picture first of the chicken to ensure that there is nothing on the bird before we inoculate it ourselves. Now we're going to inoculate the bird with fecal contamination that we have spiked with salmonella to ensure that there is a presence of salmonella within the fecal contamination like you would see at an actual processing plant if there was fecal matter on the bird. We are going to take another picture to show that there is a presence of fecal matter. And as you can see, it shows a red dot on the chicken carcass showing where we have placed the fecal contamination on the bird. Next, to ensure that there is salmonella in the fecal matter that we have inoculated on the bird, we are going to swab it again and place that applicator also into a tube. It is a buffer to help grow any microbe that may be found in the fecal matter. After we have swabbed that for fecal contamination, we are going to take it over to the sink. And this is kind of to reenact what they do at the rehang station when they find fecal contamination. So they come to a station where they rinse the bird off and ensuring that all of the fecal contamination is off. After we spray it off, we are now going to swab again to make sure to ensure if there is a absence or presence of salmonella. where we did inoculate the bird with the fecal matter. They are now going to hang the bird that has been washed off. And now we are going to take a picture. And even though that it has been washed off, you can still see the presence of where the fecal contamination is. So even though we can't see it with the naked eye, we still are able to detect it with this spectral camera using RGB.
So we are able to detect that invisible fecal matter, and with our camera system, with our vision system. And now we have a way to improve food safety even more in the poultry processing plants. This project is funded by USDA ARS in Maryland, and also we are working in conjunction with a company who's developing these cameras for commercial purposes, commercial use in the industry. So now with our research, those algorithms and that database can be used to build better camera vision systems, and that can directly go into the processing plants and then help our stakeholders. We have absolutely out-of-the-box thinkers in our lab. These out-of-the-box thinkers are always looking to do something amazing, and I give them the leverage to say, go for it, just do it. And so my graduate student, Sophia Sierra, she came to me and said, hey, I would like to work on packaging. And I said, okay, great. And she said, I want to work on packaging that is biodegradable. Fabulous. And so she had certain ideas, but I said, what more can we do with this packaging? What else can we do? And I said, why don't we do something called chicken packed in chicken? She's like, what do you mean? And I said, why don't we look at some biomolecules from chicken that can be incorporated into packaging film that will help in improving its quality in terms of stretchability, its ability to transfer oxygen or transfer moisture. It provides some strength to it, and so on and so forth.
So this is my thesis research for my master. So I developed biodegradable packaging film. So and everybody knows the problem with the plastic. So we are trying to get a solution, and one of the solutions is create a biodegradable packaging. So in this case, I made this. So this is made from different components: chicken gelatin, that is the degraded part of the chicken collagen. So this collagen is extracted from skin, and then I did this for months. So I had to do preliminaries, and with which ingredients I can use, get integrated good, which temperature can I use for dry or to mix it, and then after I created that, I say, okay, that biodegradable packaging also have challenges. So one of the challenges that the people or the industry is worried about that have raised the concern of the food safety, because these packaging have nutrients, so have protein, have polysaccharides. So the microorganisms can use these nutrients and growth. So one of the solutions that we found is make this biodegradable packaging also with antimicrobial. So we are working with Listeria monocytogenes, which is a very dangerous pathogens for kids, for immune system, the people that have immune system problems, and old people. So then we add antimicrobial that is specific for Listeria monocytogenes, and then after that we are doing a long experiment antimicrobial analysis and also shelf life with this packaging. So we packed our biodegradable packaging with the bologna. So we are using beef bologna, and then I store them in fridge like the normally bologna is stored, and then we are sampling each week to see the reduction, if we get reduction. So at the beginning I inoculate the Listeria in all the samples, and then we have different treatments, and then I am sampling each week to see what is happening over there in the fridge. So you can see here that we have the controls, so we can see a lot of and many colonies of Listeria pathogens, and then we have these plates that have my biodegradable packaging with antimicrobial.
So Sophia has been really the brainchild behind this. All in all, it's a win-win for everybody. It's a great project. We are very, very proud. I'm very proud that Sophia came up with this concept, this idea, and that she was absolutely gung-ho about it. And she has gained a lot of interest from the industry and from a lot of stakeholders as well. So it is a very unique product and a very unique project that is coming out of our lab. I think that it is time for us to look at big picture, because the problems that our industry, food industry specifically, for my stakeholders, my people, the problems are going to get complicated and even more complex over the period of time. Be it through climate change, be it through carbon footprints, be it through reducing economic costs, improving food security. Any of those problems are highly complex that are combined with social geopolitical situations as well. So a food scientist can work in their labs and they can get things done. A poultry scientist can do it as well in their own little lab and stuff, but we will not be able to solve the big problems that the world is facing. For us to solve the big problems the world is facing, we need to have this convergent approach where we have multi-sectoral, multidisciplinary scientists who are coming together to solve that those big complex problems. One person, one department cannot solve it ever. You will have to merge these different fields. You have to break the boundaries, because at the end of the day, we are there for the stakeholders. We are there for the people. We are there because the hard-earned money of the taxpayers paid for our salaries, our labs, our buildings, even the grants we get. It is the taxpayers' money, and it is for us to actually be responsible to our taxpayers, to our stakeholders, by creating an impact. And the way to create an impact is to bring down these silos, merge these fields together, and look above and beyond ourselves, our labs, our departments, our universities, so that we can solve these big picture problems that are going to be faced by our people around the world.
Food safety has changed a lot. When I'm teaching my students, I like to start back in during the Napoleonic Wars, because really that was one of the first times people started to consider food safety, right? Because Napoleon had his armies going all over Europe and couldn't figure out how to bring enough fresh food with them, and they were tired of, I guess, salted meat all the time, and that's when canning was invented by a guy named Nicholas Appert. And since then, we've been trying to continue to improve the process of keeping safe food around for a long enough time for us to eat it, right? And so in the United States, some of the big food safety work started happening around the turn of the century, and I guess by that I mean the 20th century right now. But when some food safety regulations came into place, they kind of realized what was happening in those meat production plants, like in the Chicago stockyards and all of that, and so came up with the Pure Food and Drug Act and created the Food Safety Inspection Service, and since then, we've just been continuously improving. We have a lot of new technologies that we can use to help us maintain food safety. We have, even really simple things like having hide pullers in our meat plants that will take the hide off of the beef carcasses, so you don't have a person in there making lots of cuts with a knife. Because if you think about an animal, right, they have this skin on the outside that's basically protecting the meat from any contamination, and muscle in a living animal or a living creature is pretty much sterile. So until we actually remove the hide and remove the gut from the animal, we consider the meat sterile and safe, right? So it's those kind of key operations that have the potential to introduce bacteria or other pathogens to the meat itself. So if you're doing something like pulling off the hide, the fewer times that you have to touch the carcass with a knife during that, the better. And so there's there are so many things that we've used to improve food safety. And we're going to continue to use to improve food safety because we're never perfect. And that's why it's such a fun field to be in. We're at the advent of all of these new ideas and technologies and knowledge, and figuring out new ways to detect pathogens and then prevent them from growing. So my research involves, kind of in an overarching way, my research is looking at the relationship between microbial communities that are already present in an environment and pathogens that may or may not be there, and how those microbial communities or microbiomes influence pathogen survival, right? So one kind of major project I have going right now is we are looking at meat processing plants, so the facility itself, and specifically drains in the facility, because we clean facilities really well, but sometimes the drains get missed a little bit, just like you wash your kitchen, but maybe forget to wash your sink. So we're looking at drains in the meat processing plant. In these locations, the way bacteria survive is in something called biofilms, which is like this sugar matrix that bacteria can build that helps them, kind of protects them. It's like building a little house or something, right? The best example of a biofilm is plaque in your teeth, right? Plaque help the bacteria survive in your teeth. Biofilms help bacteria survive in a meat processing facility. So I'm actually growing biofilms on little bits of stainless steel, just to kind of make my own example that I can then take out of the plant and study in the lab. So what I'm looking at in these biofilms is specifically kind of what organisms are just hanging out. I know it's a lot of a bacterium called Pseudomonas, because Pseudomonas grows really well in cold and wet places, and a lot of bacteria don't grow in cold places. They only grow in warm places, like your intestines. So I want to see what's there, and if the microbiome in one plant looks like the microbiome in the plant down the road, or if locations have a really specific signature. That's the first thing. But then the second and more exciting thing is I'm going to take a bacterium called Listeria monocytogenes. And I'm going to put Listeria on the biofilms and see if Listeria joins the biofilm or not, basically. It's like a playground, right? You throw the new kid in there to all of the kids on the playground, let them come and play with them and play their soccer game or whatever, or do they kind of exclude them and push them out and make them be a loner? It's just like that, but bacteria instead. So that's the idea there. And if it works out the way I'm hoping, I'll be able to kind of model and predict whether Listeria is likely to survive in an environment based on the microorganisms that are already there, which I think will help meat processors kind of figure out how to design their sanitation plans and what their risk of Listeria is. The other thing I'm really interested in is food waste. Globally, we waste about 1/3 of the food we produce. It's crazy. And when we're talking about meat specifically, most of the food waste occurs either in the grocery store or at the home, right? Because the product reaches its use-by date before it's purchased or eaten, and so people just toss it out. And so I want to harness the power of bacteria to understand what is happening during meat spoilage and see if we can predict and get better use-by dates. A lot, because they're pretty conservative. You don't want to risk telling people meat is still fine to eat when it's not. So you kind of usually knock a couple days off of it if you're a meat seller, knock a couple days off your use-by date to make sure that people are going to eat it in time, right? But if we can come up with dates that are more accurate and better, then maybe we can extend that just long enough that the product actually gets sold or can get used somehow rather than just thrown away. So what I'm doing is I'm looking at the microbes that are growing on meat during spoilage. And really, microbes are primarily what drives spoilage. If you leave meat in the back of your fridge too long, it turns green and slimy. That slime is bacteria. So that's kind of what we're talking about here. And those bacteria, they're not necessarily pathogenic, right? Which means they're not like E. coli or Salmonella or Listeria that does something specific to your body that makes you sick. Those bacteria have kind of evolved to attack human bodies or animal bodies, right? These spoilage bacteria have instead evolved just to eat meat and hang out, right? So they can make you sick if you eat too many of them because your body gets grossed out by it, but they're not actually doing anything attacking your body specifically. So, they're not gonna kill you. You'll just feel crummy for a day. So I'm looking at those bacteria and the community that they're growing in, and it actually changes over time as meat spoils. You know, it might start out with a lot of different bacteria, and then one that's really good at breaking down protein kind of takes over, and then another one that's really good at eating the protein breakdown products like amino acids takes over, and so on and so on. So if we can kind of create machine learning predictive models that estimate how long till spoilage based on what that initial microbiome looked like, I think we can come up and generate some better use by or sell by dates. I think a major misconception people have is what sell by, use by expiration dates mean, right? We think, and studies have shown, like 70% of people make their eating decisions based on the use by date, which is great. That's what they're there for. But it's why we do that. That's kind of the misconception. People think it says that the food is not safe to eat anymore after the sell by date, but if it's before the sell by date, it's fine. And that's risky because if a meat product has been contaminated with a pathogen, it's gonna be there from day zero, from day one, right? The day you buy it will be risky, even if it hasn't reached the sell by date yet. So don't think that just because it's not at its expiration date that it's fine, right? That's why that one's scary. What that sell by or use by date is actually telling you, it's measuring the quality or the shelf life of that meat product, right? It's measuring the time until the product is spoiled, which just means it is too gross to eat. It's not a measure of when it's safe to eat, it's a measure of how disgusting it is, right? So that's why people tell you, oh, you don't actually need to worry about it, just sniff it and you should be able to tell. And I'm not necessarily recommending that, I'm just saying that that's kind of what the use by date is measuring, right? How long until it smells sour, until it's slimy, until there are too many non-pathogenic bacteria growing on it for you to want to eat it. So just because it's before its sell by date doesn't mean it's safe, and just because it's after doesn't mean it's not safe. You know, when I can tell students something I'm passionate about and see them actually learn to care about it as well, that's the most exciting part of my day. And you know, I have students come to me with ideas and they say, oh, you know, I have this research idea. Do you think this is something we could work on in the future? And I can say yes. Like, that's the best thing ever, is getting to work with people and see students who are as enthusiastic about this as I am.
I am a graduate student under the provision of Dr. Belk. I am pursuing my master's degree in meat science, but mainly in the discipline of animal sciences. At Auburn, we have the Lambert Powell Meat Laboratory, and this is basically a location where we are able to educate students, we are able to do research, and basically build up students who are trying to get a feel for the meat industry, so they can come in with no experience at all and they learn every aspect from harvesting the animal to fabricating, processing the meat, and even as far as doing retail things. And so just being able to be there and have all those resources there, even use it as an education facility for producers or students like in 4-H or FFA, we're able to carry out those things and learn all the different aspects of that. So 2 projects that I'm actually working on right now are things that are dealing with the antemortem side of the animal and the postmortem side of the animal. The antemortem side of the animal, we're looking at transportation stress. This is something that producers are actually looking after a lot more now, that it's becoming, I wouldn't say an issue, but something that has become a factor of thinking within the beef producer side of the industry. And basically we're seeing how much stress, transportation stress specifically, can affect the animal's gut microbiome. So we all know that animals get on a trailer, they travel around from one point to another in the industry, and they poop everywhere, their species, all the things. And we're looking at that because this can be a factor of what can put meat at risk when they're getting harvested. So what we're doing is we're basically looking at seeing how transportation stress can affect the animal's gut microbiome and seeing if that can lead to a higher prevalence of E. coli and Salmonella, which is something that we're concerned about because that's something that can affect our food and our health. The postmortem side of my project is looking at shelf life and how we can basically use cold storage technology to prolong ground beef in patty forms
as long as they can without it being perishable, since meat is a very perishable product. So we're trying to see different types of technology to keep it on the shelf as long as possible so we don't have to waste it. There's definitely a lot of independent work in this field, even though there's a lot of collaborations that can be done with different areas. You know, doing a lot of your own independent work and having grit and perseverance. There's a lot of trials within this industry where you have to keep going at it again because maybe the certain methods that you used didn't work correctly, so you have to try it again. Being able to lead people well is really important because even though you do independent work in your own studies, you also need to be able to command a team properly and get everybody motivated and excited for whatever project's being done. Obviously, we have talked about previously, there's a lot of companies out there that deal with meat, and so you have to think about different positions in those companies have to lead well, and so that's another important aspect of a person in this. And also just someone that has the passion and the drive to say, hey, let's figure some stuff out, let's do some problem solving, and get it done. With this degree, I'm looking to move on into the food industry, so looking at different meat companies and fulfilling a role of being a supervisor and kind of working up in that direction of administration. So just being able to take control of the quality departments and just being able to make sure that we give out good product and safe product for consumers and people that are hungry and ready to eat.
Oh my gosh, there are so many jobs in food safety. It depends really on how long you want to go to school, right? Because you can go to school and become a veterinarian or a doctor or a PhD, and then you can work places like universities doing the research, or the government doing research, or even like the CDC doing outbreak tracking. And I really love epidemiology and like how we can figure out where this pathogen that's causing this disease originated and solve the problem at the root. And that's a very cool career track if you like this. But of course, you'd have to go to school for a long time. If you want to go to school for a little bit shorter of a time, all of the food companies out there need food safety specialists. They have people looking at their lines, looking at the restaurants they distribute to, looking at the animals that come in and saying where things are good, where things are bad, figuring that out. We usually refer to that as quality assurance. If you want to be, in a meat plant, in a facility, or you can work maybe on the desk job sort of side where you're figuring out the food safety plans and making sure that everything is, the paperwork is good, or you're paying people correctly. You could be a meat inspector. That is a great job. They make a pretty good amount of money and they have really solid, like specific work hours. So if you're trying to work with like a family or something, that's a great way to go. And I also tell all my students, because most of my students want to be veterinarians, that you need veterinarian meat inspectors. So, work on that job for 3 years, have a nice stable career, pay off your student loans, and then you can go and open your own like dog practice or whatever you want to do. Or if you like being in the lab with just a bachelor's or master's degree, you can just do lab work. You can work at a site that tests meat products for food safety, sees what pathogens are there. You can work at restaurants. You could work for state and local governments. And I'm sure I'm missing something, but there's always going to be careers in food safety because people are always going to be worried about it. And every time we solve one problem, another one pops up. So lots of job security for sure.
Meat science is so important because people don't realize what goes into it to make a great ribeye, a great New York strip, a great sirloin that you can just pick up off the shelf. There's so many different avenues of this one piece of steak that we can look at. But what's really important is that we're able to educate people and keep them safe when it comes to cooking meat, working with meat at home, and also being able to study that, bringing that to people and keeping them from being hungry. I think that's why it's so important that we do what we do, not only to keep meat on the shelf longer, to keep from wasting, give them a good diet, not wasting anything from the animal, just using all our resources that we can and being as sustainable as possible. That's something of great importance in our industry.
My name is Danny Reams, and I'm a Regional Extension Agent for Food Safety and Quality with the Alabama Cooperative Extension System. We share information on safe food practices. So that can be how to preserve food or how to prepare food safely in some cases. We talk about safety in manufacturing operations and in restaurants. We also do classes on demand for things like cooking for groups, for clients or churches or nonprofits who want to cook for large groups of people, because it's very different than cooking for a small group or for your family. There are things that you have to consider as far as cooling times and holding times. We also teach classes on things like hand washing and other safe food preparation classes as they're requested. There's not really a typical work day for a regional agent with food safety. We do such a variety of programs. We talk to clients about a variety of topics every day, and we try to respond to things that are trending, questions that are relevant. Like when COVID hit, we tried to talk about food safety in COVID. There was a surge in popularity of food preservation, so we started really emphasizing our food preservation component even more. But we also still do those Serve Safe Manager classes and exams and the food processor classes. It's always something different.
All right, so we get a lot of questions throughout the year, and it really is dependent on the season. So during the spring and summertime, we'll get a lot of canning related questions, and we'll also get a lot of questions in relation to cottage food law because the farmers markets are in full swing. We'll get questions from the farmers about being able to sell at the farmers market and what they're able or what they're needing to sell. During the hurricane season, we'll get a lot of questions about freezer and refrigerator safety if their power goes out. And then during the hunting season, we'll get some questions when it comes to preserving their game, their wild game, or anything that they were hunting for that time period.
So some of the classes that we teach are for home food preservation, and home food preservation is really important. It's something that was part of the traditional beginnings of Extension, and it's something that people are still interested in today. Home food preservation is important because it allows you to preserve your crop for later use when it's not in season. It also can allow you to buy things in bulk and save some money. But if you preserve food incorrectly, it can go bad, and in some cases it can even kill a person. So we teach people the research-based methods to preserve food safely for them and their families. For restaurants and businesses, they have to meet certain requirements from the FDA or from local regulatory authorities. And in order to do that, a lot of those businesses have to have somebody who's taken an approved food safety class. And they have to learn how to handle food safely, because when you're working and making food for the public, you may be dealing with people and making food for people who have weakened immune systems or other considerations. So we teach people how to safely do that so that that food can go out and be good and positive and not result in an outbreak. We also teach classes for processors who want to do things like acidified foods, like if you want to make a barbecue sauce. So we teach classes that they would need in order to do that legally, and we also provide testing assistance to make sure that the pH of those products is low enough for them to be safe. And the last thing that I want to say for home consumers, we are working diligently to complete our curriculum for cottage food law. So Alabama has a law that allows people to make certain things in their home and sell them to the public, which is really an incredible opportunity. It allows people to test their product in a sense and see how it's going to go before they go to the next level to be a manufacturer. Or in some cases, they just do cottage foods as a hobby or as a side business, and that's as far as they want to go with it. But in order to do that, they need to take a food safety class, and they need to understand some basic food safety principles and some things about allergens. And so we talk to people on a regular basis about the requirements of cottage foods and how they can do that safely, and we will have the class rolled out soon so that we'll be able to offer that as well. One thing that I love about Extension is that we really make the information that we have available to people throughout the state. So we have agents who are based in several counties throughout the state, and they cover several counties in their region, and that allows us to take information to people where they are when they need it. And we're really working hard to offer a variety of formats. We're very excited to be able to offer the virtual options that we offer now. We also still think it's very important though to go into the communities and do hands-on in-person workshops.
So our team provides a lot of workshops throughout the year. With food preservation, we currently have done over 50 online and in person just last year. We do have other workshops that we provide, and it's really based on the needs in the area that we provide the services to. So in my county in Mobile, I provide ServSafe classes once a month, and then other surrounding areas I may provide that class twice a year. So it really depends on the need and what our county constituents are needing. So one thing great about with Extension is you can partner with other departments. Some of the other departments that we partner with are the Home Grounds Department, Commercial Horticulture, we can partner with too as well. And then we've also recently started partnering with the Human Science.
So today we did our garden and pantry workshop with the food safety team, and it's really a fun day because we get to overlap two teams together, food safety and horticulture. And what I love about these workshops is the fact that a client can come in and get the gardening information starting from ground up to when they're cooking it, when they're consuming it. And a lot of times people forget one of those aspects, and so my job is to help teach people the safety component with growing their own food, as far as using the right chemicals that are labeled for a vegetable garden, or using the right compost, not harvesting too soon after they spray an herbicide, really being mindful of the things that they're implementing in their garden. And that's really the main component of a lot of these workshops, is a lot of people are wanting to know what goes into their food. They're wanting to know their inputs so they know what they're consuming at the end. And so a lot of times clients will, it could be a couple of months before they might be able to come to different workshops to get all of that information. So it's a really good way for clients to come in, get really good information about, correctly growing their own food, how to prepare it correctly, how to store it correctly, and make sure they get the A to Z of the different components of growing and consuming your own food.
We take the product from the garden and then show them how to grow that product and grow it correctly, and so they get the best yield from their crop. And then we show them how to can it, to preserve it, if it needs to be water bath canned or if it needs to be pressure canned. We show them how to even drying and fermentation, freezing. So we do workshops on all of these different types of food preservation techniques.
The interesting thing about food is that when you go into food, everybody has a background or a history with food. Some professions that you go into, you learn on the job or you learn in a class, but we come into food with all of the history of what our grandparents or our parents or our friends have done. Maybe we have some experience cooking ourselves at that point. And so one of the biggest things is helping people to understand some things that have changed. For instance, in the area of food preservation, years ago we didn't recommend acid for tomatoes because they were acidic enough that they could be safely water bath canned without a problem. But over the years we've raised tomatoes for things that sell well. And what sells well with tomatoes? Consumers tend to like a sweet tomato. But that means that the acid has been reduced over the years as we've continued to cultivate tomatoes to get that sweeter tomato. So now current recommendations require the addition of some acid to make sure that the tomatoes are acidic enough to be safely water bath canned. And that's really important because if they're not acidic enough, you can get the growth of Clostridium botulinum and the toxin that it produces, which causes an illness called botulism, which can be fatal. So sometimes just helping people to understand changes like that is a really big part of what we do.
This information is important to share to the public because, there's so many resources out there that are not valid resources that you can get information. And I think people go to the internet, they go to blogs, to different websites, and that information is not always accurate. So you want to be sure that We are here to give you accurate research-based information, and so that's why Extension is important. Anything that is from the National Center for Home Food Preservation, anything that is, we actually have a food preservation book called Food Preservation in Alabama, and any of those resources that you get from Extension, they are research-based food preservation recipes that are, tested and approved for processing time so that they are safe for the consumer.
So food safety is always going to be around. Food safety is based on science, and science is always changing. So with food safety and quality in our team, we are learning the best practices through research, through conferences, through experience with other extension agencies. So the information that we're providing you today will probably end up changing from a year from now, and you'll hear it directly from us when that information does change.
I always tell people I love to see the light bulb go off, and so when I'm teaching and you just see that aha moment, somebody has something that you can tell that they have just learned something. And I have several people that they'll come to a workshop and they'll say that their garden's growing great now, or they changed one little thing, and that's, to me, a lot of our disciplines. If you just know a few tips and tricks, it can kind of save you a lot of energy and money, and you are more successful. And so watching people be successful with the information that you provide is one, but really being able to see that light bulb go off, knowing that they learned something, is really what I love to do every single day. So if you're unsure about any of these questions, food preservation, home horticulture, several other disciplines, you can always go to www.aces.edu and type and use the search box, or you can stop by your local extension office. There's an extension office in every county in Alabama, and there will be someone there to help you with their answer. If they don't know it, then we can definitely work to find that answer for you as well.
The reason we can trust our food supply is because of the work of food scientists and microbiologists and meat scientists and legislators and lobbyists and meat companies who have really worked to reduce food safety issues as much as possible, right? A long time ago, the meat industry agreed that food safety was going to be a non-competitive element, right? You'll see these companies compete on how good their food tastes and how cheap it is and whether it's organic or not, or how the chickens were raised, but they don't compete on whether or not it's safe. We decided that we're going to share what we know about food safety as much as we can, right? Because we've agreed that that is a human health, a humanitarian priority. That being said, people do still get sick, right? The only acceptable number of foodborne illnesses is 0. So we are still improving and still reducing foodborne illness. And that's why I think my work and the work of other food scientists and meat microbiologists is important.
Food safety, especially in poultry, is going to be very important due to we have more than 9 billion chicken are produced every single year, and that is the most consumed, or one of the most consumed meats that we have over the world. And being able to help prevent the foodborne pathogens such as Salmonella, E. coli, and Listeria and Camelobacter is going to be very important. Just making sure that we're all safe and sound and eating right.
So in the future, I definitely see more people trying to grow their own food, trying to figure out how to can and preserve their own fruits and vegetables, because I feel like we're in an area now where people are more in tune with where's my food coming from, what are the inputs to that food. Again, it's really hard sometimes to find that local produce in certain areas of the state. So being able to grow it in your own backyard and then can it and preserve it and keep it gives you a little bit of comfort knowing you know where that food came from, and you also have something to eat. Hopefully nothing like another pandemic happens again, but kind of a sense of security there.
I have traveled around the world. I have seen people struggle with food. Food sector is very important, and providing safe food is very important to people all over the world. And for me, it was my duty, I felt from the beginning, to really create an impact on the people around the world through me and through my science. So since my early ages, like when I was 12 and 13, I have always thought of becoming a scientist, and my motto in life is science for the benefit of mankind. And I have followed that every single day since that time. So I am very, very fortunate to work in the field that I love, and I create an impact. Very few people have the pleasure and the honor of working in the field where they're absolutely gung-ho about. A lot of times people don't love their jobs, and people are like, well, I need to do something else on the side. For me, this is my life, this is my love, this is what I do. And so it doesn't become a job anymore. It becomes a public and people-centric approach so that I can help them out. Through my work, I want to reach, and I have reached, people at the grassroots level, and I have worked with mega corporations to help make food safe, improve quality of food, and improve shelf life of food as well.